Hello friends, Utkarsh here. Today I am going to discuss topic applications of inverse trigonometric functions. So, inverse trigonometric functions are the inverse of trigonometric functions with suitably restricted domains. The inverse trigonometric functions are used to determine angle measure when at least two sides of right angle triangle are known. Inverse trigonometric functions are widely used in engineering, navigation, physics, and geometry. In general, if we know the trigonometric ratio but not the angle, then we can use the corresponding inverse trigonometric function to find the angle. This is expressed mathematically as follows. Mathematics is not just about learning formulas from the book. We should also know how to apply them in our daily life to make things easier. So let us understand inverse trigonometric functions by example, which is a real life example of Pisa, also known as Leaning Tower of Pisa. The Leaning Tower of Pisa is an excellent example to understand the application of inverse trigonometry. It is a remarkable architectural structure from medieval Europe. The tower began to tilt during the construction due to an inadequate foundation on the ground. The tilt increased in the decades, and the rate at which the tower started to lean was such that it would have fallen with time. So, in order to preserve the historical architectural masterpiece, an international team of geotechnicians, engineers, mathematicians, structural engineers, and historians were gathered in an attempt to save the famous landmark. From the figure, we can see that the height of the tower acts as a hypotenuse, and its distance from the center acts as a perpendicular. The famous structure has the value of its perpendicular and hypotenuse. As we all know, sin theta is equal to perpendicular on hypotenuse, which implies sin theta is equal to 5.45 divided by 58.36, which implies sin theta is equal to 0.09338, which implies theta is equal to sine inverse 0.09338, which implies theta is equal to 5.3580 degree, that is theta is equal to 5.4 degree approx. In this way, they use the concept of inverse trigonometry to find the angle at which the tower was leaning. That the tower should be moved a little, and the foundations were reinforced, and the tower was itself encircled with steel cables, due to which the tower was moved by approx by 1.55 meters. As a result, the top of the tower was displaced horizontally 3.9 meters from the center, and the height reduced to 56.67 meters. From the figure, we can see that the height of the tower acts as hypotenuse, and its distance from the center acts as a perpendicular. So again they made calculations with new values of perpendicular and hypotenuse. By applying the same formula, which was sin theta is equal to perpendicular upon hypotenuse, which implies sin theta is equal to 3.9 divided by 56.67, which implies sin theta is equal to 0.0688, which implies theta is equal to sine inverse of 0.688, which implies theta is equal to 3.94 degrees. That gave theta is equal to 3.9 degree approx. So finally the tower was tilted at an angle of 3.9 degrees and declared safe for the next 300 years. From the above example, we have understood the importance of mathematics in our daily lives. Moving towards the next step, you should also try to visualize things in real life from mathematical point of view.